factorials on Friday. Factorials, you started a number going down by 1 till you get to 1, correct? So for example, if I had the number 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1. And we're going to practice putting in our calculator again so remember where it is. So you do 6, math, and then you arrow to the left till you get to PRB. And you pick number 4, factorial symbol. Enter, enter, and you get 720. Right? Now, what if they gave me 100 factorial over 99 factorial? You could type it into your calculator, yes, or you could go 100 times 99 times 98 times 99 to 1, and then 99 times 98 times 1. Or we could look at it as an expanded form and see if there's some way we could possibly cancel. So let's look at it that way, not with our calculators, because we can do this really fast. The answer is actually 100. So 100 is 100 times 99 times 98 times 97, and it would just keep going, correct? All the way to 1, would it not? Okay. Now this would be 99 times 98 times 97 times all the way to 1. Yes? And then because it's multiplication, if it was addition, and you did rationals last year, if you had like x plus 2, you need to have an x plus 2 in the bottom to cancel, because addition has to have that connector, right? But when it's multiplication, if you have something that's the same on the top as on the bottom, you can just cancel them off. So cancels, 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 the dots cancel, the 1 cancels, and I get 100. Correct? Do you see what I'm saying? What all cancels? Now, times dot 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 times 1 is not really mathematically the best way of writing something. So what we could have done is we start off with the bigger factorial. This is going to help us when we get to variables, which is in the notes. Start off with the biggest number first and expand it until it matches the bottom. Okay? So I could go 100 times 99, and then it would technically go times 98 all the way to 1, correct? How could I represent 99 all the way to 1 in a better way? 99 factorial, correct? Do we agree? And then on the bottom I have 99 factorial, cancel, cancel, and I'm left with 100. Yeah? Okay, you guys try this one. I don't want you to put it in your calculator until you have simplified it. Go. Okay. So we have to decide which one is bigger. Because the bigger one can become the smaller one, right? But the smaller one can't become the bigger one. So which one's bigger, the numerator or the denominator, the top or the bottom? Numerator. So we have 98 times 97 times 96 times 95. Now it matches, correct? 95 factorial. Then all over 95 factorial. They cancel off. What's 98 times 97 times 96? Rachel, what'd you get? Yeah. 512,566. Sorry, what was it? 576? Yeah? Okay, so that is how we can do it with numbers. What happens when we get variables? So in your notes, it starts here. We have n factorial, in general, n factorial. So n factorial starts at a variable n. So this works for all values of n numbers in the number system. Starts at n, and then it goes down by 1. So if I start at n, what's 1 less than n? You're going to multiply by, go away, computer needs to be restarted, n minus 1. And then what's 1 less than n minus 1? N minus 2. What's 1 less than that? N minus 3. And then I could technically go factorial. It would just keep going for life. Now you don't know how long it's going to go because at current, n is n. N can be any number. It could be 3, it could be 5, it could be 1,000, it could be 1,000,000, right? The bigger the number, the longer that pattern would carry on. So like if I had 3 factorial, well this would be 3, this would be 2, this would be 1, and I would actually stop here, right? So it's all dependent on what the heck your n is. Okay. So same rule goes for simplifying when it has variables. What did we do when we simplified when it was numbers? We took the biggest number and we broke it down till it matched the smaller one. Yeah? Same thing happens here. What is bigger if I give you these two? You tell me. If I give you n and n minus 1, which one is bigger? N. What if I give you n plus 2 and n? Which one's bigger? N plus 2. Now this is the ones that people mess up. What if I give you n minus 1 and n minus 3? Which one's bigger? N minus 1. A lot of people want to pick the 3 because 3 is a bigger number. But if you take any number, any minus 1 from it, any number minus 3 from it, that one's going to be smaller. Correct? Okay. So here it says, simplify the following expression. Leave the answer in product form. So that just means in factor, those factors side by side when it's done. It's not going to be like the answer 7. It could be, but it might not. Where appropriate, do not expand it. So if I had an n plus 2 beside an n plus 3, that's it. I would stop. I wouldn't FOIL it together. I wouldn't distribute it like that. So n plus 2 and n, which one's bigger? N plus 2. So the numerator is bigger than the denominator. So I'm going to expand the numerator, correct? So n plus 2. And now I'm going to expand it till it matches the denominator. What's 1 less than n plus 2? N plus 1. Still not matching the denominator. What's 1 less than n plus 1? N. Now I match the denominator. So I'm going to put a factorial because it's going to keep going on for life. Correct? Do you agree? Then we have the n factorial in the denominator. And now they can cancel off. And now a lot of people will just box their answer here. That is not done. That is not simplified, right? The simplified form of that would be taking the canceled ones off and rewriting it. So you will lose marks if you don't rewrite it. It is not simplified. N plus 2, n plus 1. It does not want you to expand. That's what it said above. Just put it in factored form, product form, so it stays like that. You try B. N minus 1 is bigger, so I'm going to leave the numerator the way it is. N minus 2 factorial. The denominator is n minus 1, so I'm going to go n minus 1. What's 1 less than n minus 1? N minus 2. And now this is where I want to see how your fraction simplifying works. What you put as the answer. So, n minus 2 factorial cancels, n minus 2 factorial cancels. Fun fact, those canceling signs are just ones. They're just ones. Like when I cancel this with this, these just become ones. Do you agree? So like if I had 8 divided by 8, and I canceled it off, that's a 1. That's a 1. I'm now left with 1. Because it's 1 divided by 1, correct? If I had 8 over 4, same thing. This would cancel, become a 2. This would cancel, it would become a 1. This one has to cancel off. This would be a 2 times 1 technically. Right, so you'd end up with 2. So, what is the actual answer to this? Yeah.
1 over bracket and then minus 2 bracket.
What, n minus 1? Yeah, you just didn't look, but you, yes, that's right.
No, I had it here.
You were going by your remembering, but yes, I know you know. So it's 1 over is the key thing. So a lot of people will give me the answer just n minus 1, but remember when your numerator cancels off, you need to keep that 1. If your denominator cancels, do you need to keep it? No, it'd be like 1 over 7, you have to keep the 1, correct? But if it was 7 over 1, that's just the same as 7. All right. So why do we care about that? Well, we care about that because The perms and coms formula, permutation and combination formula, is this NPR NCR video, which I'm going to give you a formula sheet right after this. It's this one and this one, which uses factorials. So we have to be able to cancel, right? To be able to solve. We're doing this algebraically. Now I know a whole bunch of people, you could plug in 6 and 7 and 8 and see if one of those gets you 42. That's great. Except if it says algebraically, you're getting no marks, because that's guess and check. So algebraically means we have to do some mathematics. Okay? So what we're going to do is rewrite it first. N factorial over n minus 2 factorial equals 42. What is our first step always? Figure out which one is bigger, correct? And then expand it to cancel off the smaller. Yes? So which one's bigger, n or n minus 2 factorial? N, right? So our n is what we're going to expand. So we're going to have n, and that's 1 less than n minus 1, 1 less than that, n minus 2 factorial over n minus 2 factorial. I have to restart this computer. Equals 42. What's on the left stays on the left, what's on the right stays on the right, correct? Okay. Cancel, cancel. And now we're back to grade 11. Every step after this is grade 11. We're no grade 12 math after this. So we have n minus 1 equals 42. If I ask this in the solving quadratics unit of grade 11, what would you have to do next? Distribute. Distribute the n in. That's completely correct. So we're going to distribute that through. So we're going to get n times n is n squared. N times negative 1 is negative n equals 42. What was your rule? So when it's a linear equation, so when it's degree 1 or just a variable x or n or whatever it may be, your goal is to isolate x and y, whatever it is, get it equal to a number and be done. But then last year you learned about quadratics, and quadratics have a squared in them, correct? What do you always have to do in order to solve a quadratic? Not unless you would square root if it was like n squared equals 9, square root, absolutely. So if it was a difference of squares, you'd move your 9 over, square root both sides. Listen to that stupid little n sitting in there that's ruining our life. Yep. You have to get it equal to 0 when you have that n in there, because you're going to have to factor it. So we're going to subtract that 42 over. And we get n squared minus n minus 42 equals 0. Now there are certain steps you have to show in order to get full marks. So what I do when I do these is I say what times what gets me the outside two numbers. So what times what equals 1 times negative 42 is negative 42. If you forget how to factor, no big deal. What you need to do is if you forget how to do a grade 10 or 11 skill, everyone paying attention? I don't have the time to reteach all the grade 10 and 11 skills in this room. However, I'm going to show it to you. And if after you've taught it, unless it's on a Tuesday, which is today, because Tuesday I have supervision scheduled help and all of lunch, but any other day and any morning, come in and be like, Mrs. Lepp, I don't remember how to factor. And I'll be like, cool. And then we'll just practice it for like 5 minutes and you'll be like, I remember how to factor. And we're like, cool. And then you carry on in your ways. Or you can sit in denial land. Denial land is a terrible place to sit in. You sit in there and you're like, I know how to factor, but I don't. But I don't want to ask because that makes me look stupid, so I'm not going to ask. So you sit in denial land, and you denial all the way to the test, and then you get to this question you can't factor. And then your mark sucks, which is terrible, right? So we go straight through past denial, right to acceptance. And then we find this stuff, and we're like, I can't factor. And I'm like, cool, let's go out and factor. It's not a big deal. Like, I don't expect that you remember every math skill you've learned in your life like that, right? All right. So we say, what times what equals negative 42? And then what plus what equals the middle? So what plus what equals negative 1? And I know that that is long and arduous to write that out, but I write it out every time because then I can double check and I don't get a stupid error because I picked the wrong numbers. So what multiplies to give me negative 42 and adds to give me negative 1? Yeah.
Negative 7 and positive 6.
Yes. Negative 7 and positive 6. Now, luckily in this one, we don't have to do decomposition because it has a 1 in front. The moment it has a 1 in front of your n squared, not a negative 1, but a positive 1, we can go right to brackets. Okay? So we're going to go n minus 7, n plus 6 equals 0. Now, you guys might think that what I'm telling you is crazy. I only tell you stuff that you need to do in order to get 100% on your diploma. Okay? So if I'm being stickly about something, it's because I know you need to be able to do it that way in order to get 100. We agree? What they told us when we were marking is, you can't just go from this, everyone paying attention, because this will lose you 0.5 in a written response, it's the same. You can't just go from this to 7 and negative 6. You have to do the middle step where you set each factor itself equal to 0. They told we will take away 0.5. So some people by the end of the year still don't do it, and I'm like, you have no chance of ever getting 100 if this is on, because you refuse to write them out separately. It is what they're going to do when they mark it, okay? So I'm just going to be straight up with you. I'm going to mark it the same in order to stop you from doing that for the diploma. All right? So what does that mean? That means I have to take this factor, n minus 7, equal to 0. And I have to take this factor, n plus 6, and set it equal to 0. So I can't skip that step. You might be like, well, that's crazy. That's if you want full marks. I can pretend it's not true, but it is. Okay? All right. Then you can just, instead of, you can add the 7 over, or you can go to this. They don't care. That's fine. All right? You can subtract the 6 over by showing it, or you can just go right to n equals negative 6. That's fine. The catch here is, every time you solve for a variable, you should always check and see if it works. Because a lot of the time it doesn't work, because maybe you made math wrong, you messed in your mathing, or it's extraneous, it doesn't work. Now, can everyone put the pencils down, because I need you to understand the difference between does not exist and extraneous, because you guys don't. Well, maybe you do, but every year previous to you did not, okay? But maybe you guys are just like raw stars and all completely understand, and that's good too. Extraneous means I got a solution, I plug it back into the original, and left side does not equal right side. It can't work. It's extraneous. It's outside the scope. It doesn't work. I got a solution. Nope, don't work. No solution means I go to factor it. I put it in my, it doesn't factor. I put it into the quadratic formula, and I get a negative under my square root. Because you can't square root a negative number, right? That means there wasn't a solution. There is no solution. No solution exists, right? Because I can't actually get a solution. So the difference between extraneous means I got a solution, I plugged it back in, left side doesn't equal right side. No solution means I can't get a solution. I can't get 7, I can't get 6, I can't get anything, because often it happens when you have to use the quadratic formula and there's a negative under it. Because you can't take the square root of the negative number. Make sense? Okay, pick up pencil. So let's look at this one. If I take the 7 and plug it back in, I'm going to do a check below it. I would go 7 factorial over 7 minus 2 factorial equals 42. And that's true because this will be 7 factorial over 5 factorial. The 5s will cancel off and I'll be left with 7 times 6. So 42 equals 42. So I checked it, it's good. Right? Then I try negative 6. Negative 6 factorial over negative 6 minus 2 factorial equals 42. Fun fact, I have negative 6 factorial written up there. Where does the factorial stop at? Technically, it stops at 1, right? So can it be negative? Can I have a negative factorial if it stops at 1? No. So some people, paying attention, assume the moment I get a negative number, that's the extraneous one. Well, if it happened to have been 8, like say it was 8 minus n factorial, then that would be 8 minus a minus 6. factorial. That's 14. That's fine, right? So you can't just assume because your answer's negative, it's gone. You have to plug it back in and show that that results in a negative number, a negative factorial. Make sense? How do I say it's extraneous? This is very important and very important the way you write it. So what you do is, this is an answer, it's good. I box it, yes? This is an answer, I can box it or circle it, it doesn't really matter. This means when I circle it or I box it, it means it's an answer. But it's an extraneous answer, right? It doesn't exist, so I have to reject it. And the way I reject it is I circle it or I box it. I don't know why, I really like circling the ones that are extraneous. It's a thing. I'm sorry, I can box it. And then you literally draw, blue boxes. You literally draw a line right through it and then reject it. And then you have to write extraneous. It has to sound out as extraneous. I would like it spelled right, but if we can sound it out as extraneous, it'll be good. If it like comes out as the word extraterrestrial, yeah. It's happened. The X words come out like exponential, X. They're like, I know it's X something about extra. It's very close, but not right. Okay? Extraneous. Pick it out. All right. So, we're going to look at, let's skip that for now. I'm just going to have you guys do these. We'll save 3 for when we do it actually bigger. 1 and 2. And here are your answers. Now, if you're like, cool, I can just write down the answers. No, the answers are there to see if you're right. The answers aren't there for you to just write them. That's not helpful.